Welcome everybody, have a seat. We're gonna get started. Thank you for joining this GitOpsCon session. Plenty of seating up here in the front, seating over there. Make room if you need to, looks like people are coming in. So today's talk is, well, I can't say today's talk. I guess you have to read it because it's bleeped out. But how the heck do I deploy that many apps to that many clusters? And this is a story that comes out of Adobe, which has done this very effectively. So to introduce myself, my name is Dan Garfield. I am the Chief Open Source Officer and co-founder of a company called CodeFresh. We are the first and still only company to fully commercialize on the Argo project, on Argo workflows, on Argo events, Argo CD, Argo rollouts. We launched our enterprise Argo offering about 3 years ago. And so we've seen really great adoption and pick up on that. I'm also an Argo project maintainer, and I also helped create GitOps, the GitOps standard. And so GitOpsCon is something that is like a progenitor, like coming out of that. So that's very cool for me. You can find me on Twitter at todaywasawesome. And then this is my co-speaker, Mike Tougeron, who is a lead cloud engineer at Adobe. You'll notice that he is not on the stage with me. Unfortunately, he was in a car accident last week, and he said he needs to be home. He said he's fine. He says, tell everybody I'm fine, but also just give the talk without me there. So I said, no problem. I'm going to present all your work as if it's my own. So appreciate your your help on that. So how did this start? Well, this started actually at KubeCon EU last year. I happened to meet the folks at Adobe, and they were looking for advice on how they could architect their Argo rollout. And basically, they were in the midst of this huge modernization project where they were using old school tooling, and they wanted to start taking advantage of Argo tooling to fix everything they were doing and to do it the right way. And so we started talking about their approaches and their architecture, and this led to a pretty fun collaboration for me to help them get up and running and figure out the right stuff to do. So this is the goal that they had. The goal was provide infrastructure for Adobe's new developer platform. And their developer platform has about 285 clusters across 28 regions, 20,000 nodes, about 2,000 GPUs, and you need to install about 100 Helm charts per cluster. So this is stuff like, Prometheus, Grafana, and all the other tooling that the infrastructure team needs to be present on each cluster that people are going to be using. And this is a baseline. So this was the very start of the project. In fact, it's grown quite a bit even since then, and it's already getting close to 1 million CPUs. So it's a fairly robust project. There are a lot of developers involved that they're working with, and so there's a chance to do a lot of impact on this. So what we did, Terraform apply. That's it. Thanks. Cool. No, in fact, this is not the solution. So what we did, where they were coming from, they had a big Python monolith. They had a lot of Azure ARM templates, AWS CloudFormation templates. Kostas and I were just talking before the talk about CloudFormation templates and just shaking. A lot of manifest templating that was very custom, and then of course a lot of imperative operations. And the whole thrust of GitOps is let's get away from imperative, let's start doing declarative. And so we wanted to move to 100% declarative structure, taking advantage of Cluster API for cluster provisioning, Argo CD, use the entire suite, using Helm charts, and then using some operators where we needed to. And so this is where a lot of the power of Argo CD is going to really come in and shine. And you can see I've got my AI-generated logo for Cluster API there. It's a stack of turtles. So if you're not familiar with Cluster API, it's basically a way you can provision clusters declaratively. So you can create a custom resource inside of a Kubernetes cluster and that custom resource was then responsible for spinning up a new Kubernetes cluster. So how does Argo CD work? Now, how many of you are more than casual Argo CD users, just by raise of hands? Okay, so like a good chunk of the audience, but some of you are still casual, maybe new to it. So even if you've been doing Argo CD for a long time, maybe this concept might feel a little bit new, but the concept of an application in Argo, if you think about it, it's really a policy. Okay, so you have your desired state, and yes, it's defined in Git. It's probably a bunch of manifests. It's maybe some customize or some Helm charts or whatever. And then you have your actual state that's living on your cluster, and then in between that you have your application, and that application is the source and definition of that policy. So, for example, here if you look at this application here, it's called Hello Vancouver, because Hello Vancouver! Thanks. Appreciate that enthusiasm, bringing it back to me. So we have this ability in Argo CD to do something called ignore differences. Now, how does this work? Well, Argo, when we take a source of truth, we render out Kubernetes manifests, then we compare that against the actual state, and then we can apply our policy, and we can say, oh, I actually don't want you to track the replicas. In fact, I have a controller that does that. So don't ignore any changes to the replica set. That's not an issue. Or maybe I'm using Kyverno and it adds a lot of annotations onto things. And so I'm going to ignore those differences because Kyverno is in charge of Kyverno stuff. And I'm just going to be in charge of my stuff. And so the ability to do ignore differences and actually compare state and get a view of what's different between your source of truth and what's happening in the actual state, that's something that's very unique to Argo CD. And so that's a really important part of this, and it's going to go into what we're talking about. So when we talk about these kinds of policies, they also include things like self-healing. So if something is changed in production, does that mean that I should overwrite that change? Should I mark it as out of sync, or should I leave it? And you can set different policies for different specific fields and things like that. So that's really powerful for Argo CD. And then many of you have probably already heard of the app of apps pattern. So if an application is Kubernetes manifests, well, with a policy, and I just showed you what one looks like, this is just a custom resource that I have created inside my Kubernetes cluster. Well, that means that I can have an application point at a folder with just a bunch of applications in it. This is called app of apps. So app of apps is really great because it's just YAML, and this is really fantastic for end user space. So I can create, the way that at CodeFresh we actually refer to app of apps internally, and we in our application we mark app of apps, is we just call it Git source app, because that's how we think about it. We think this is an application that represents a Git source that has a bunch of other applications in it. And then the next kind of meta layer up above beyond that are application sets. And application sets allow you to programmatically generate applications, right? So we've got our application policy, we can have an app of apps, and now we can have an application set. And it's basically two components. It's generators, and I'll tell you what those can be in a second, and then it's templates. And templates just represent, if I'm going to generate an application, this is what it's going to look like, and you're going to fill in the details. And we've got a ton of generators within Argo CD. We have a list generator, so you can do a list of items. Cluster, for every cluster added to Argo CD, you can generate applications. You can do a Git generator. You can do a matrix where you combine them. So you can combine multiple generators together. Merge, source code management providers. Pull request is an especially interesting one because you can say anytime somebody opens a pull request, generate an application. And of course, we also have this custom decision resource generator. So there is a common misconception, and some of the people in the room are like, we know, get on with it. The reason I bring this up, there are some people that don't necessarily know, but the other reason that I bring this up is because there's a really big common misconception in the community that application sets are app of apps 2.0. And I'll talk to people sometimes and they'll say, I don't use app of apps. I use application sets. Well, good, that's great, I'm glad you use it. For a use case. So almost every single Argo CD instance that I deploy has both. In fact, I use application sets to generate off of Git app of apps. So I'm actually using them together. And so this is a great pattern. There are more tools in your toolbox. Okay, so the one that we're going to leverage for Adobe here is going to be the cluster generator. So if you add a cluster to Argo CD, that's as simple as creating a secret. So it's just declarative, right? So I can just create a secret on my cluster where Argo CD lives, and I can pass in, there are a million different authentication schemes I can use, and I can leverage a secrets manager, and I can use external secrets and whatever. And what I can do is, for each cluster that I add, I can generate my applications. And so I can say, every time I add a cluster, I want Prometheus added to it, and I want Grafana added to it, and I want these things, and I want them to have this kind of policy. So that's very possible to do, and that's going to be really important for this strategy. So here's the plan. We've got about 75 apps that need to be installed. Sometimes it's more like 100 apps as a baseline, and each of those has at least 10 resources, and then we have 275 clusters. So now we have 200,000 resources for Argo CD to manage. Ding! Right? Sounds great. So Argo CD is very scalable, and there's some really great content that, well, I was going to say there's some really great content that I put together. There's some really good content out there, and I did put together some of it. But you can search for like scaling Argo CD securely in 2023. You'll find a blog post there. And you can use, Argo CD has a mode called HA. Most people don't use HA. How many people are using Argo CD HA today? Okay, a smaller number than the people who said they weren't just casual users. So Argo CD HA just adds high availability, and it allows you to have more scalability. And there are a ton of knobs you can tweak. Now, the focus of this talk is not necessarily how to scale Argo CD, though we will talk about some strategies. If you want some performance data, there's a talk that I gave at KubeCon 2 weeks ago that covers some of that, and there's another talk that I gave at ArgoCon last year that talks about that. So this is actually going to be pretty intense, and in our case, it's going to be too much for a single Argo CD instance to handle. So no problem. We're just going to layer it on. Now, there are a couple of different Argo architectural patterns. So this is a blog post. You can find it, a comprehensive overview of Argo CD architectures in 2023. You can Google that. You can Google CodeFresh Argo architectures. You're going to find it. But this comprehensive guide, and it's fairly, I mean, it goes pretty in depth, but they're basically 4 models. So there's hub and spoke. So that's where you have an Argo CD instance and you connect all your clusters into it. So cluster generator is perfect for that use case because I can create a single application set. That Argo CD instance can then just generate applications for all the connected Kubernetes clusters. The next is split instance. So this is basically where you have part of Argo CD living in different clusters. And there are some open source solutions for that. And there are some specific use cases where that makes sense. Like, for instance, you want to talk to something behind the firewall, or you want to distribute the load of what repo server is doing, which is essentially reconciliating with clusters. They're standalone, so this is very popular for edge clusters. So if you have a cluster, let's say, every Starbucks has a cluster. I don't know about Tim Hortons. I didn't check. I'll have to go behind the counter after the conference is over and see if they have a Kubernetes cluster back there. But this is very popular for Edge, where you basically have an Argo CD instance in each location. And that's really great because it's resilient and they can each just reconcile themselves. And I'll tell you that I'm aware of some use cases where those locations aren't stationary, they're mobile. And you might have them on vehicles or transport of some kind. So that's interesting. And then finally, there's the control plane model. And the control plane model is you essentially introduce a managing overhead control plane that all of your instances can be managed by. So this is something that CodeFresh does. You can use it for free. You can go check it out at codefresh.io and try it out. You can also, in this case, we're going to be doing sort of getting partial way there with a kind of modification off the control plane pattern, which is doing an Argo of Argos. So this is where you set up an Argo CD instance. It connects to X clusters. You then install Argo on those clusters using Argo CD, and then those Argo CD instances can then connect to additional clusters and deploy and manage from there. Of course, you can also scale up Argo CD components individually, like repo server is the most common one. You can tweak how many kubectl, like Kubernetes API requests it's making. You can do all kinds of those things. So this setup for Adobe does offer us a lot of resilience. So one of the reasons that going with one giant Argo CD instance may not be your cup of tea is if it goes down, you can't update anything. So having multiple Argo CD instances is very valuable because, okay, something can be going wrong over here and it's not going to affect everything else. So that's a much better situation to be in. So that's one reason you might want to split it up. These are all fully managed in Git, so nobody's clicking through and setting these up. These are all bootstrapped and automated so that every instance is fully self-managing once it's bootstrapped. And it also allows us to do testing and progressing apps between clusters and instances. So we can actually start changes in one instance of Argo CD and generate them onto like a staging and then a production. And we can also manage regions. So we can have different areas that are managed by different clusters, and then we can manage the rollout between these different areas. So CodeFresh does something very similar to this. So I mentioned CodeFresh has a control plane. We also offer fully hosted Argo CD environments, and the way that we do that is we leverage CodeFresh, which is the enterprise version of Argo CD, to maintain all of these community versions of Argo CD in their own V clusters. And so we basically have one instance that spins up and manages thousands of instances. So there's not that much work that the parent instance of Argo CD actually has to do to keep them all running. And there's a great talk on that that you can check out that Kostas gave at KubeCon EU 2 weeks ago. And it's called How We Securely Scaled Multi-Tenancy with vCluster, Crossplane, and Argo CD. Great YouTube video. And you should go skip the next session and watch it. And then you can ask Kostas about it when he gives his talk this afternoon. He's giving another talk. So from a Git perspective, a couple of strategies. I mentioned earlier, you can mix and match application sets and app of apps. So one of the things that we do with like I mentioned, CodeFresh, we have an Argo CD instance that's managing every customer Argo CD instance. And what we do is we basically use application sets to generate that. And then we bootstrap in an app of apps into each one so the user can show up and they have a Git repo and they can just throw their apps at it, and the client Argo CD instance will pick those up and deploy them, and they can still operate it without even looking at the UI. They don't have to. They can just operate it entirely from Git if they want to. So that's a really nice pattern. That helps a lot. So with Adobe's flow, we're going to handle this a little bit differently. We're going to be leveraging Argo workflows and Argo CD and Argo events. And basically the way it works is this. When a new cluster is created, that's a cluster API definition, right? So we can use Argo events to listen for the creation of clusters. And whenever a cluster is created, it doesn't matter if it's created manually, if it's created with Git or whatever, it's going to automatically pick up that event and trigger an Argo workflow. That Argo workflow will collect the details from the config map on that cluster, and then it will find the proper Argo CD instance and cluster to deploy to based on the metadata. And then it will upsert those cluster details into that Argo instance, which will then allow the application set in Argo CD to automatically bootstrap and manage all of the applications on the cluster. Does that make sense? Everybody follow me, or does that get confusing? It's actually a pretty simple workflow if you think about it. Cluster is created, triggers a workflow that grabs the details, pushes them to Argo CD, and then Argo CD uses application sets to dynamically generate all the applications for that cluster so that we have everything we need from a system space, from a security standpoint, from a monitoring standpoint, and then the users can just start deploying to the cluster. So what does that config map look like? So the config map that is created for these for cluster API shows things like does this cluster include ARM? Does it include GPUs? Is it Kata containers and not just container D? Is there a specific Argo CD instance that you want to go to? That's optional. Is it all that metadata that we need. So that just lives in a config map. And so that's short enough that we can consume it and then push it onto the cluster details. Now there is another feature that can help us here called application set progressive rollouts. And application set progressive rollouts is a pretty new feature to Argo CD. I think it debuted in 2.6, and we're currently in 2.6. The release candidate for 2.7 just came out a few weeks ago. And this is considered an alpha feature, and I want to call that out. But this is what you can do with it. So in Adobe's case, we have all these clusters, right? And we're using application sets now to manage all of the system space, the security and whatnot. And we have a nice mechanism so that whenever a cluster is created, it automatically gets bootstrapped with all the components and it's all managed very nicely. Well, what progressive rollouts allows us to do is we can say, these clusters actually represent regions. And I don't want to deploy to all these regions at once. I want you to deploy to one region at a time, run some sort of health check, and then progress on to the next one. That way, if there's an issue, my blast radius is small. And this is an issue that you have to think about with GitOps, because when you have the power to make a commit that triggers all of your deployments or triggers all your changes, that means you have the power to make a commit that destroys all of them, right? It's a two-edged sword. If you can bootstrap everything in one command, you can destroy everything in one command. So it's very powerful. So the ability to do progressive rollouts, that's an excellent feature. So this is a community contribution. So it was really cool that somebody came to the Argo project and they said, hey, we want to do progressive rollouts. Here's how we think it would work. And as maintainers, we worked with them and helped them get this in. So it's very cool that way, because you can basically say, well, these are prod clusters, these are staging clusters, or these are the regions, and these are the progressive, and this is how I want to go. So this is what it looks like. So application sets, you can see that we're looking at an application set here, and you can see that we have different cluster generators that we're using to specify different environments. So we've got like staging environment is getting certain versions versus prod environment is getting different versions. And then within our progressive sync, we basically can set update criteria for how these are going to roll out, and then how they're going to progress up across the instances. So this allows you to make an update and not accidentally, destroy 285 clusters. Instead, you can do an update and destroy a small percentage of those clusters. And then not destroy the rest of them. And then you can fix those ones and you'll be back up and running. So progressive rollouts is a very cool feature, and I definitely would encourage you to check it out. Again, it is in alpha, so there are a couple of gotchas. So first of all, it does not respect sync windows. Now, if you're not familiar with sync windows, in Argo CD, I mentioned applications are essentially a policy that says this is the source of truth, this is where it goes, here are the reconciliation rules. Sync windows basically dictate when can updates happen, when can the application be synchronized. And this is a really useful feature. I was talking to somebody the other day and they said, I want to be able to make it so that I can hit a button and nobody can deploy anything because there's an issue. And I don't touch anything. It's like, sync windows are for you, buddy. Turn on those sync windows and you can basically say, don't allow any synchronization to happen. Well, unless you're using progressive rollouts, because unfortunately application set progressive rollouts do not obey those yet. Sometimes it does get stuck, so it is still alpha in that way. Also, selectors are based on application template labels, not cluster labels. So that means that you can't, for example, leverage the labels that are just on the cluster object. In Argo CD, you actually have to push them up into the application object itself. So that's something to be aware of. And also, all clusters must be healthy or it could affect larger rollouts. So if a cluster is unhealthy for any reason, it may just prevent the rollout from continuing. So if you just, if your cluster is having issues for something totally unrelated, it will still stop progressive sync from happening just because one cluster in that pool happens to not have enough memory to spin up some pods or something. And then this is probably the worst one, is that if an application is stuck in pending for too long, it will then be treated by default as healthy. So you could actually have a situation where stuff isn't able to deploy and it's misunderstood as actually being healthy because it's been that way long enough. So that's not a great gotcha. But for the case of Adobe, we initially rolled this out, the progressive sync, and then with this many gotchas, we said, you know what, we're actually going to stop doing progressive sync for now, and as these issues get resolved, we're going to bring it back. So if you're looking for an opportunity to contribute to the Argo project, got one for you here. I just laid out the issues. Now you're very familiar with it. You know why they're important. We appreciate your code. Looking forward to your PR. Okay, so to wrap up here, the goal again was to provide infrastructure for Adobe's new developer platform. So we leveraged Cluster API to generate all of our clusters. We used Argo workflows and events to then trigger those clusters to be added to Argo CD. And then we used application sets to generate all the applications across all of our instances. And like I mentioned, we also have the opportunity to leverage things like app of apps still. They're not a replacement, they're not fighting each other. And this way, the infrastructure team is able to manage the baseline for all these clusters, but the end users are still able to deploy everything they need to their clusters, and everybody's doing it in a GitOps way. They're all doing it in a declarative way. They all have, self-healing. They can all take advantage of all the wonderful GitOps tooling that exists. So what's next? Well, next up is going to be hopefully getting progressive sync, progressive delivery for application sets back in there once it's ready. And then obviously looking forward to more opportunities to streamline this and find more efficiencies. But just the availability of how the application sets work, already very powerful and has put Adobe in a much better footing for managing this. Now, if this sounded interesting, if this sounded like an interesting project, this is something that I put out there a little while ago. I said, if you ever want an extra set of eyes on your Argo CD, Argo workflows, or Argo setups, my DMs are opened. I've worked with quite a few companies in the last 2 years, and well, this was like a year ago, so I should say 3 years, and have seen a lot of what works and what doesn't. No strings attached, no money, just a friendly architecture review. I have loved doing this. As an Argo maintainer, this has given me a chance to talk to a ton of teams about what's working for them, what's not working for them, and how they think about the project. I've been surprised to meet people who are like, hey, we really want to do GitOps right, so we're going to be moving everything to Argo workflows. And I'll say, okay, well, like, what do you mean by that? And it turns out that they heard Argo was really good for deploying software. And when they went to the web page, they saw Argo workflows and they said, that kind of looks like CI/CD, so I'll use that. And they're like, oh, well, I wouldn't build your strategy around that because actually this is what Argo CD is. So sometimes it's as simple as that, and sometimes it's more involved. So please feel free to hit me up on Twitter. I would love to chat with you if you've got an interesting problem, or if you just want somebody to take a look at what you're doing or get a second set of eyes. It's been great for me, and at some point I'm going to compile this into a blog post, and it helps me also figure out which things we should prioritize development on within the Argo project. I also have a free giveaway for you. So we created, and Kostas is the primary author over here, the main visionary, created a GitOps certification with Argo. And so we're offering a free code, so you can get 100% off if you use the code DanVancouver. There are not enough codes for all the people in this room, and so whoever claims them first gets them, and then they'll go away. But you'll get a full environment to run Argo CD. It'll teach you how to build your Git repos, how to do progressive delivery, how to do canary releases, how to take advantage of the different health checks, and goes much deeper than just, oh, I'm in Argo CD, I can create an application. Okay, well, how's it stored? How do you manage it? How do you change it? So that's a freebie for you. And that's it. That's my talk. Thanks for coming. I think we have a couple minutes for questions, if anybody has any questions. Yes, Nick? Could
you give me a little bit more detail on what the cluster event was and how Argo Workflows picks that up?
Yeah, so the question was, what event specifically is firing via Argo Workflows? that allows that. So it's actually just the creation. We're looking specifically for the creation of the config map that comes with Cluster API. So when you so with Argo events, you can actually say anytime a specific object is created, fire off, so any kind of object even, fire off an event that will trigger a pipeline. So it literally is, if somebody goes to bootstrap a cluster, it'll just automatically pick it up and run. And that is nice because there are some teams that still do this manually, even though they're told not to. But even if they did it manually, it would still trigger all of the downstream effects that would, and in a declarative way, that would then trigger the application sets and everything. Yeah, good question. Back here.
Basic to that one is like that flow, how much of it did you manage to do it totally declaratively, or did you have to write any controllers, operators in this because?
Yeah, so the question is, how much of this flow is declarative? Are there any imperative operations that are happening? So yeah, it's interesting. When you get into writing controllers, you write imperative operations. So like if you look at Argo CD, the code is imperative, but it's imperative so that it can consume declarative formats. So in this case, basing off of the event is pretty reliable, but like what would happen if that event didn't fire or if it misfired? Well, then we would actually have to have some kind of roll up that would say, okay, what's happening? What are all the resources that exist and update them here. So we would actually just trigger it by updating the resource, and that would re-trigger the workflow to update. And it's an upsert operation, so you can write over it again, and it's going to be idempotent, so it's not going to cause issues in that way. Argo workflows is obviously an imperative format, but as long as it's done in such a way that it's going to consume declaratively and have idempotency, we're good to go. Yeah, good question. Over here.
Could you tell us about what are some of the gotchas from a scalability perspective? And I'm looking into perspective like the crazy idea like developers say, great, I can create a cluster just for every developer in my company.
Yeah, okay. So you've got your application sets and you're like, okay, so I want to create a cluster for every developer in my company, and there's 10,000 developers in my company. Is that a problem? Well, as I mentioned, yeah, it probably kind of is, because you need to have some way of splitting things up. Now, Argo CD does have scalability tooling in it, so you can increase the number of repo servers, and you can basically make one repo server for each cluster. Now, I've never tried to do 10,000. I think the most I've done is like 2,000 clusters. And repo server will scale up, and you're probably going to run into other scalability issues. So, for example, like if you have that many clusters and each of them has applications on it, your UI in Argo is probably just not going to load very well. So at that point, you probably want to split up and have an additional instance or have something like a control plane. So like within CodeFresh, for example, all my instances roll up into a single view, so I can just go into the control plane and I can just filter the applications. I don't care what instances they're on. So that's like an extra tool for scalability. So that's something to be aware of. But there are definitely some other ones, and there's some good blog posts on it, and happy to chat with you afterwards. Back here? Clusters? Oh, awesome. So that's an Argo CD talk? Excellent. So be back here at 2:20. 225, and he's going to show you 20,000 clusters on a single Argo CD instance. Oh, start with 10,000. Okay, awesome. Yeah, I'm excited to see that. Yeah, great, thank you. Any other questions? Yeah.
One more, which is at the beginning you spoke about the email differences thing in Argo CD. I'm not very familiar with Argo CD, but that to me sounded like the use case for server-side applies. And likely I don't understand the benefits of this custom syntax for server-side applies.
Well, server-side apply, so Argo CD does support server-side apply as of Argo 2.5, maybe 2.4. And server-side apply is gonna allow things like controllers to run, so they can do some modification and stuff. However, actually, you bring up an actually very interesting use case. So in the case of Argo CD, we don't do server-side apply for diffing. And the reason for that is because if we did, we would have to hit the Kubernetes API infinitely more. And so from a scalability perspective, we found that that was probably a bad idea. And so we actually re-implement, most people don't know this, we actually re-implemented, and by we, I mean not me, but within the Argo project, we re-implemented the Kubernetes API to create fake server-side apply dry run for diffing. So when it comes to the diffing engine, it's a matter of efficiency, because if you actually did it off of a server-side apply dry run, then it would allow the controllers to run, and so you would get a more accurate perspective, but it would be a challenge from a scalability standpoint. So the ignore differences stuff actually works really well because you can basically delegate fields and delegate them and their responsibility to other controllers, and that ends up being a simpler way to do it and a lot more scalable. But I think you make a good point about just syntactically how it would work. I mean, you could do it that way, but it's for the scale that most people are deploying Argo CD, it would be bottleneck. Great question. I think we have time for one more. They say no more. Okay, so thanks everybody for coming. I appreciate you coming. Definitely check out Kostas's talk that's going to be later today in this same room, and this gentleman's talk with 10,000 Kubernetes clusters. That'll be excellent, and I'll be hanging out. You can find me on Twitter @TodayWasAwesome. Thank you so much.